Good evening and welcome tonight. Well, it's tonight for me anyway. Tonight we're going back to working on the basic side of things, using break to debug where it's failing for us. One of the things I did do before I started was edit out or unedit a line, this one here. Magic memory location, I don't know what it does, but I have had it commented out. Control find to find it in files, find all instances. I can find it in the labels and in the defines. AL200, and that's just a label. And it's just been defined in a label, so I have no idea what it really does. If it does anything in the way of improving or making the basic work, your guess is as good as mine. So we'll just start off with let's load basic. Loading it at DD15R. Memory size 8192, terminal width 72, and we just crash out of there. So that is still as far as we've got. So having that unedited and commented out still means it doesn't want to work. Let's see here. I'm going to leave cheats and notes. Monitor config, we don't need that anymore. The build bat, we know that works. Looks a little bit. There we go. We're not worried about the build bat. Monitor listing, we'll keep that there because it's easy to find. We're not working on the floppy disk controller or the visual display unit, the VIA. 652, we're not playing with that. Defines, not messing with that at the moment. OSI list, we're messing with that. This bit here, the defines OSI, we'll leave that as is for now. Excuse me. So whether it's Control C, could be Control C. I'm not sure what Control C does, but it could be detecting a Control C for whatever reason. And the monitor S. Okay, let's actually check to see if that is doing a Control C. So if we go back to our monitor.s, find our Control C. And so get the character, break carry, and so if carry's not set, we haven't called anything. This is actually in where are we hiding here? It's very similar to the Bravo one. And monitor is Control C. You guys can't see what I'm reading here. And I'll bring that to the left. Okay, cool. Oh yeah. Okay, so this is the other thing. If we've done a warm boot for basic, at this point we can do a warm check and find out. There we go. Fall into warm reset. F3. Warm restart entry, and so okay, so this is where we do a warm start. I'm going to make a note of that on notes. So DD15 is cold start, and and warm start is something EE. Okay, find the notes. Okay, so warm start is actually a lot lower down in the program, and ROM is loaded at. Where's ROM loaded at? I've forgotten where ROM is loaded at. Cheats. Okay, so ROM is at C0. So that means that's C0EE. What is the list? Where's the I list? Let's not worry about that. So 4664 is what we're looking for at C0EE dot C0 1. Okay. C0 EE dot C100. And that does not look like the code we're looking for. We're looking for this here, 4664. And that is not the code I'm finding. EEF 4664. Where's 4664? Oh, okay, A9A0. A9A0. Okay, so that location is actually 27. Oh, we've gone to 274 or C274. Okay, so that's the code I'm looking for. So apparently warm start is supposed to be lower, but it's not. It is a lot higher. And two C74 if it was jumping to that. Does it jump to the warm boot? Apparently this all should run as compiled. It's not going to do a jump. It should do a jump to C0 EE. And nope. Okay, cool. Okay, so C274R. Okay. So to get it to run, we've got to do a cold start, let it fail, and then do a warm boot. That's a bit strange, but no, we're not. We're back into the yep. Whatever it did, it didn't do it. 2C274 run. Okay. Run. Break. Okay. Let's see here. What to do? You know what? Clear carry, RTS. Let's see if this works. Alright, let's turn that off. Program it. Okay, so if Control C is now off, it should just do return to sender, return to from subroutine. Yeah, that's up the right way. Okay, cool. Let's try that again. So instead of having one copy of BASIC, I had 2 copies of BASIC. I just programmed it. I didn't load the BASIC. Alright, where are we hiding? Alright, let's program it this time. Okay, back to the source code, back to the programmer, the computer. Just restart it. Okay, so that didn't start up as nice as I thought it would. Let's see. DD15R. Actually, let's do the other one, which is run basic, and I'm pretty sure basic is FF37. Okay, so two changes we're going to do. One is we are not going to run that way. We're going to do the other way in, which is FF37R, which does the run basic code. So let's step through that bit first. Where are we hiding? Where's the run basic code? All the way up the top. So we're first printing off a message, setting the decimal, loading the stack, and clearing the carry, and then jumping to basic. We may not need to set decimal, but I really would like to know why it is falling through for the EEPROM not working properly there. Because some of it does work properly, some of it doesn't. To me it feels like it is failing to put an address in somewhere. Let's get rid of that. Yeah, you can't see the find command. Alright, let's try it. Loading basic, memory size. Failed there. Reboot. Actually, let's do a hard reboot. Okay, so FF37R. We'll get 8192. It's in decimal mode, so that may fail. So we do DD15R, memory size 8192. Width, okay, so the decimal it doesn't like. 72. That works to a point. Okay, so next change we're going to do in here is where are we hiding? Going to remove SED. And I just got rid of one I really want to use, which is defines.s. Has basic. And we're doing the AS Intel code as well. Okay, so the has basic bit means that, go to the monitor, when we're up through show message over and out. Okay, cool. Up through here. So if defined has Intel, if defined has basic. L means load Intel. M equals run basic. Now, that should work. Let's try this with a new processor. No errors in the compilation. And load the file. Turn off the computer. Okay, verified. Let's turn on the computer. Okay, that's different. Okay, starting Intel transfer, and this probably will still fail. Let's grab that. Yep, that's still broken. That's now broken. Basic works. Cool. Happy with that. Okay, so what's so different about typing in the jump compared to the other bit? Now when okay, so run exam. So it's just the same as a jump. What part of the code is failing for us? Okay, so that's the difference between a warm boot and a cold boot. Okay, so back to monitor and okay, let's clear the carry and is there a clear flags command or is it just clear everything? So clear carry, clear decimal, clear interrupt, clear overflow. There's no clear every other flag. Alright. It's like one thing works, then the next thing doesn't work. And for this bit here, I've probably broken it somewhere. I'll have to compare the code to another program. Okay, we'll just get rid of the Intel stuff. Now, why is it not? Okay, let's have a look back through to monitor. Okay. .ndef has FTC. We're defining that as Don't ask. Don't ask why I just did that. That's not what I wanted. That's what I wanted. I selected the wrong monitor. I went monitor.s and I can't burn that to the EEPROM. Not yet anyway. Alright. Let's try it this time. It's back in the computer. Switch on, that's upset the apple cart. Okay, why did that not work? Where's my editor? There it is. Okay, so E100 looks like it's still loading the code at E100 and no, E67, E167, no, E127 and E1 E2 and where's my monitor dot list? Okay, so down the bottom here we see that E127 is where we've been loaded to the reset vector, and the reset vector is being set to E127 just here. And it didn't want to do it. Okay. Maybe something to do with the where it's been set up. And the other thing is, where's our text? Let's get rid of time. No, that's the wrong one. 00. Why don't you guys tell me I was editing the wrong one? Alright, down through here. Let's just get rid of time. And where is it here? Time and string 0D, because we want to do a enter. Okay, so the other reason why it might not have printed it was because there was a 00 in the time code, and that would mean that is the end of the line. So we cannot use the time as a good measure of when it was compiled. So at this stage, I know there's version. Let's just not worry about it. Okay, so build up that. That works. Let's load it into the EEPROM. EEPROM's already in the programmer. Program it. Okay, so after this bit of chasing my tail, we will go attack the brake handler and see if we can get it to work for us as well. So loading basic and things didn't work, and where was the warm boot? C274. That's the warm boot. Okay, so that just falls over. We'll power cycle it. DD15R, memory size 8192, terminal width 72. That's okay. C274R, okay. There we go. So at this point it's in the command interpreter and it's doing something here. So when it's in here, it's probably where the prompt is. That's where the prompt is. It's okay, saying, okay, let's do stuff. Let's go. And we're ready. And we're loading the data in, and it goes, nah, I'm falling over because I cannot read or write to a place. So if it's doing the break command, E602 is where it's failing. And E602, that is in the EEPROM. That is in my BIOS. Okay, it's cool. So we know now where it is failing. And monitor listing E602. Going too far. E602. Delay. Why is E6? Oh, E4. Right. What is E602? E64. E5. Okay, so it's calling E602. And E602 does not relate to any location. I changed that. That's not right. Send delay monitor echo load Intel code. This is really the only thing I've changed here is the locations here. So if CR, if they are the wrong size, ooh, it could be the wrong size. So move and check, they can be the same places, but and the clear block, because we're not going to be calling them. Well, we could be calling them one after the other, but this is the bit here. So 50, 51, so that's the AL. 37 is the program status word. It's actually flags. So what does that look like for us? Now 37 in hex means that, let's see which flags have been triggered. Okay, where's the flags in the book? Let's not go to the book. Want that one there. (6502) processor flags, and what we'll do is I will bring you guys up to the web page and editor browser. Okay, so we've got the flags here, and I'm trying to find the mouse. So the carry flag is set, the 0 flag is set, the interrupt flag is set. Wait, is that? No, that's the interrupt flag is set, and so those three are set. Interrupt, Z, and carry flag. The interrupt should not be set because it's not an interrupt. The bind BCD one decimal is not set. The B flag, just not going to tell me. Doesn't know, but that's set. NV overflow flag is set, and negative flag is set as well. Let's have a closer look at those flags, because there's one there that should be set, but it's not set, and that is a bit of a concern. 1, 2, 3, 4. Oh, it is set. Sorry, it is set. One 6 5. Right, let's see. Six, 5. Unless okay, so right, that's not how I thought it is set. but it's just how the processor responds. So if it's set, it means we are accepting interrupts. If it's not set, then we're not accepting interrupts. So that is okay. So we're not worried about that. It's the break, this one here, the break one. So the break flag, and if that's set, let's just check to make sure it's because do we unset it? I don't think we can unset it. $172, $175, $172. Oh, right, there we go. Okay, if that is set to 1, it is a break, and it's been break. So how do we turn that off if we need to? Okay. So let's not worry about the break flag. We know it's been set. And the interrupt flag, it just means that it accepts interrupts. What we're concerned about is the location E602. Why are we doing a jump to or call to E602? When what is in the location of E602? So E60. What is in that location? That's why it gets. Okay, so that's all breaks. Now E6. It's not. It's E5. F0 to E5 FF, and that's all breaks as well. Right. E5 E0 to E5 EF. Okay, so E5 00 to E5 FF. Okay, so we're just trying to find out where that code ends, and it ends E560. That's the last time we can have possibly an instruction is there. So it does look like we're jumping to E602. And where's my monitor listening? OSI listening. Listing. Oh, labels. There'll be labels, won't there? No, it's not. Sorry, I just got rid of putty. And I'll bring you back to the editor. Did a few things outside of what you weren't seeing. So I've just gone through and had a look to see where we are finding code and where E602 is related to. So I'm quite confident it is a jump to E602. The processor is trying to run code at that location and it is not working as expected. So let's try and find E602 in here. We're looking for the actual labels. So I don't think there's labels. There's a label file, it is 16 kilobytes, and there's also an object file. Okay, so L200, we've got our monitor, get rid of that. It's right at the bottom. Token address table is at C00. Okay, so that's in ROM. Okay, so anything there with a C is in ROM, which is a good thing. C695 is ROM. Ah, why didn't I use this before? Alright. Scroll all the way up to the top of the top of the labels. C, D, and E is yeah, E is the BIOS. We're going to start calling a BIOS. So here's our cold start, DD15, and we are looking for RAM start. DC, not sure what that one does. Decimal table and decimal table. At the moment, I'm just having a look. Go string out. Con billion. I'm not sure what that's about. And that's floating point. Cool. So signed floats there. MFA, MAF, factorial. These are all in D, so that's good. Shift right. And so these are just all subroutines then. Check bump. "48 minutes, alright. CBA1 exit. At least we're not getting any syntax errors now, which is a good thing. DC, so error entry, because we haven't got any error printing, print nulls. It just quits without any error. And we can see that it's calling a place that it shouldn't be calling. Why it is calling that area, I don't know. CC there restarts the warm boot. There's our restart. Waiting for it to come up. Check memory. Memory error C24C. So these two here could be failing in there as well, but we've done that memory check. QT OK, QT in, QT error, QT break. So these are our error. Okay, these are our error functions, and then there's the error bits and pieces through here. And these are memory locations. So 02468A looks like 2 bytes in size. And more instructions. So these are all on the 0 page too. So another thing to look out for is if anything in here is going into the stack for whatever reason. If it's overwriting the stack, then that is going to cause us trouble. So again here, AB, 9E, 9C, 1C. So getting quite high up there, and they are variables again in the 0 page. There will be a 0. This is related to our defines here. Stack top, space for go sub. So ZP 0 page starts down through here, and that's what that is related to. And we want that one there. So number of tokens, okay, still C's. 97 is token print. Not sure what size that is. Okay, token go to, and then we've got our functions. Dummy start, way down the start. Character get, string, assign, argument. So not even close to 100. Again in the 0 page, and input buffer, stack. Some of these might also be values as well. Stack to stack. These are our functions we're calling. Save, load, which are just return to sender, as Control C, character output, and read key. And that's calling the right locations. RAM starts 300, width 2. It's locations for storage, I guess. And then config small, they're, yep. So some of them do look like they're double ups, but they're not going to be double ups. They're going to be data, all depending on how that is interpreted. Some of them will be locations, and again, it's whether you've got the pound sign, the hash symbol in front of the value, which will set it whether it's a absolute value or a indirect value or just a value, if that makes sense. And stack top, and that's been used as a value, not as a location. So what we did see this bin here, the stack 2. In our OFSI defined, we do not have a stack location, but we've got an OSI config, which set the 0 page there. Go back to the original copy of OSI config. Where are we hiding here? Nope. Okay, so that there is the original OSI config, and really all we should need to change is the start from A to 0. And I have changed that value there. So let's just change it to an F. Control save, get rid of the old one. So that brings it back in line with the original 0 page. And what we can do is compile it. Reload it, and turn that off. And where are we hiding here? Cool, that should have compiled it. It's off. Now if this works, it means that I'll fix the error. I don't have to do any more debugging. I can jump around and punch the air because I'm in a good mood. Doesn't sound like it though, I'm just tired. It was a late night. Load. Gone too far. And we can program that to the right one. Alright, let's bring this up. So at the moment, I'm going to bring, where is my editor? Okay, so switch it on, load it, basic things, doesn't want to know about it. It was working, now it's not. I've done something wrong. DD15, which is the cold boot. Memory size 8192. Terminal width 72. Back to its 50.60. And apparently that's where it fails. It's at 37.2b. So does look like random data. Let's try doing a warm. $37.2b. Okay. Okay, so let's see here. Okay, so program.s is where we start off on. Okay, so error, line input, line editing, tokenize, detokenize, basic program memory management. So this is where I can do. Can I move that to there? No, I cannot. Move to other view, and I want OSI list. Yep, and we go control find. No, that's in warm. Okay, so restart. So that's the cold warm restart entry here. And we are okay, left shift rotate Z14. So we're Z1, we don't want the warm reboot, we want the cold one. Did I look for cold or warm? Okay, we didn't get the right one. So cold is defined in header.s. Huh. Cold start, restart. But we're not doing the cold start, then a restart. We're doing initiate.s. Okay. KDB, otherwise it is CBM. Missing that. To TX, transfer X to S, load A. So those are the restart vectors. And then we're not AIM95. So width and width 2, and from there just trying to figure out where it loads, does the QT memory size, question memory size, so we know we're getting to here, and string out, so it is doing the string out NX in, so that would be calling NX in text pointer, and then this is where it gets to compare 41 to written by, so that's where it's written by, so we know that's doing that bit. Where's written by? Nope. Written by, so it's jumping to written by, which is QT written by, string outs, and then cold starts. Oh, where does it go after QT written by? Break equal. Is it? Okay, let's try something, because in that header, this one here, it does cold start, restart. And if I do go through here, where is it? Run basic. Let's say we get rid for now. Change that, get rid of that. Oops. Because that could be causing issues. Okay, jump basic address and then JMP string to basic warm. Because what happens is that when we do the warm start thing, it is back into the monitor, and the monitor's like, yeah, no, let's not worry about that. And then the other thing we need to do is that if it does come out of the monitor, which I'm pretty sure it's done, we will redo Control C, so let's get that rid of that and back up to here. Oh, I've lost it again. And we get it to jump all the way down to FF reset. Okay, so basic cold start, basic warm start, jump to reset after it comes out of restart, reset. So that means that does this mean this will work? I don't know. I'm not clutching at straws. Okay, so builds, we can turn the processor off. Okay, so that's programmed. Okay, so I cannot hit DD15 now, because if we hit DD15, it returns out of basic, expecting to go into a warm start. Comes out of basic at that point. It then goes back into the monitor. The monitor then trashes some areas where basic is set up, and then when we do the warm start, it's like trying to use those trashed areas, so it's not going to work. So we need to call. Where's my monitor.list? We need to call. One of two ways we need to do this. One of them is just press the M button, or call it at E4B2, and M works. Why? A0. Why does it want to call A0 for some reason? That could be just random data. So let's power cycle it. It's clear. So that could be random data. That's just random data. 50. Okay, so 50.60. we've cleared 50.60. And let's try pressing the M button again. Memory size 8192. Whatever it's done, it didn't like the enter key. I wonder if it's because I pressed the wrong enter key. And there's that address. So that means at that address it has tried to to run code, and at 00A003, but 00A0, that was in our list, wasn't it? So 3, 4. Token then, which doesn't make sense. It's why so low? Okay, alright, let's do a what's the listing? E4B2. So let's just try E4B2. Alright, power cycle E4B2R. Okay, so 8192 back to there. No. And power cycle it does okay, and this point it should do. Oh right, I see what I've done. I definitely see what I've done. This bit here, DD10, that's where we're jumping to. That's not the address that I'm jumping to. I'm jumping to DD15. And that's probably the big difference, is where we're jumping to. Now where are we hiding here? DD155. Cool. So memory size and pages. .56 bytes. Cool. And we're not actually there, we started there. But we want to do that. Turn that off, upload that. Okay, so who wants to put some money on that it works this time? I've already jinxed it. Okay, so what's happening when we're jumping to DD15 instead, DD10 instead of DD15? Let's have a quick look at the at the code. First we'll put that in, and I'll bring up my terminal window, load it. Okay. Let's look here. OSI listing, and we'll try and find cold. Cold start, find it again. So cold start. So DD15. DD15 is that one there, and was it this one down through here? I cannot remember which one it is. I know DD15 will be closer to the cold start than the warm start one. I think it's here. And it's changing the stack and a few other things. Okay. It didn't work. OSI listing. Okay, so just got macros at the top, which do expand into other things. And I'm just checking here to see what else. Okay, so what we're looking here is the 0 page. So I've just gone through and just checking to see what if it is setting the 0 pages to the correct places for the offsets for these bits. I cannot see why it should not be. The other thing is that if it's doing the reset or the break or illegal instruction, that could be just a red herring. But where is it actually jumping to? 3723. So let's find everything with 37 in it. There's that one. There's that one. $37.23. Try 37.23 with a okay. The only other thing I can think of is that we're assuming it's coming back to that place, but it doesn't know that it's coming back to that place at all. It can only come back to that place via a reset. So let's see if that will work, and then let's see here. Stack top. Okay. First things first, we do that one there, which is the monitor. Then we build our basic. Okay, I need to pause in here. Don't want to pause twice because I am running that from cool. Alright, so first thing first is we turn that off. We do the monitor first. Okay, I'm going to stop in 6 minutes. This is probably not going to work. It's a good thing I'm using the same size ROM for both the BIOS and the basic as well. Okay, so things first. First things first, let's check to see if that one works. No. And yeah, because it's gone straight back into the monitor. Have I got Sigmon? Let's have a look at Sigmon. And it's a disassembly of Sigmon. So disk controller, screen RAM, keyboard, ACI, serial port. I'm just distracting myself from BASIC for the moment. What would have to change is the disk controller is a different location. The basic ROM is in a different location as well. C, screen RAM and keyboard, that's all part of the serial port, so I'd have to write a different code for that. Basic ROM routines. So this is basic cold start 1D11. I got CD15. So it'll be different. Yep, syntax error. And CD11. CD10R. Oh no, DD11R. That's the wrong place. Memory size. 8192. This better not work. See, it didn't work. So DD11, DD10, DD15. Just dumps me out. Let's see, we did DD11, we've done DD15 and DD10R. See, that's the one that completely fails. Right. Okay, so non-maskable address, IRQ address, and that will have a 0 in front of it. Okay, so screen parameters for C2, screen parameters for C1. It's probably setting F8. So that's origin. There's another way, nice way of writing origin. And this is where it starts. Probably putting a space up. Oh, backspace. New screen. Control L, Control K, line feed. Control Z. Control Shift N, bytes displayed. Move. Restart, set breakpoint, save, load, tabular display, command address mode, data mode, save registers and break. Okay. So this is the break command. Not break command, break handler. The other thing is this could also be, with the ASCII keyboard, a 1 at the most significant bit. but looking at some of the code here, it may not be. Input from ACA, Control C. I'm just trying to find out where it does basic. Okay, so this is just the rub out key handler. D, C, W, and M. Power on reset. This is where I guess it'll run. Okay, so that's loops around. Okay, so that's what we're going to find, is that one there. Okay. All it does is just jump to a cold start. Nothing special. So A0 plus 1DD11. Okay, so I might be putting myself wrong here. So let's bring up the calculator. Now we're at C000 plus 1D11 equals DD11. Alright, let us try one last thing and then I am going to call it quits for the night. Jump. Jump to the basic address. Where are we hiding here? And yes, it'll still do the warm boot if we do a have a mistake. And, well, warm boot, reset, soft reset. It's not going to even reset it. Oh yes, it will. Yep, it'll just do. Wait, it won't. It'll just do loop. Yeah, it'll just loop. Okay, that's off. Yeah, this is nasty. We're just going to get it to do a boot loop. Okay, so build, load it. If this runs, I'm going to be happy and grumpy at the same time. Okay, so power on. Syntax error. Nice. Straight to it. Syntax error. Okay, so we're just going to skip that. We're going to do the soft entry point. So when the soft entry point is redone, it will hopefully do the job. Alright, and this is the last time. So recapping what we've done tonight. I can't remember. It's been a long evening. We've gone further with basic. We know basic is going to run. It is crashing somewhere, whether it's loading in the wrong place or my program is not loading in the right. I don't know. I honestly don't know at this stage. If this works, I'll be happy. If not, I'll be indifferent to it. Last thing I want to be doing is adding breakpoints to the basic code to try and debug it, because that's gonna be fun. Alright, let's power on. Yep. Memory size. Okay, cool. So it's done a warm boot 8192 and it's done that. Cool, and then we do a reset. Cool. So straight to basic, and if it doesn't like, if basic doesn't like it, it just boots it out, and away we go. I got a feeling we have that set the same as before, and we defines OSI. We cannot touch that. We did put that in. RAM starts at 300. We can tell it to start RAM at 200. Ooh, I know. It's not going to return back to there, does it? Unless it is doing an RTS. This is when you get ideas and you're like, I really should be going to bed, but that's over this side. Initiate and try and find a RTS. There's no RTSs though. So cold start. So this is where we come in. Actually, we'll do it in the OSI listing. And we go control find. Okay, so okay, little bit of color helps. And so this is DD10, this is DD15. So we're changing the stack. No, we're storing X to be the current line. Then we're loading X. No, we're not. And then we're transferring X into the stack. So that there is all stack. Okay, where are we hiding? If define CB, not define CBM2. So this is configuring current line and stack. And if we look at the labels, the current line is in position 87. That is storing the current line, and FF. So whether it's storing the text, let's not worry about that. So list, and then transferring X into the stack. So it's now the stack points to the top. So we're loading A and the cold start addresses. And cold starts in the lower local places. I'm not worried about that, not worried about that. So load A 4C. So 4C is getting dumped into restart address, string address, jump address, the user, and then load a IRQY string user 1 2. What is that? So we know we're getting through to here. And then we memory size. No, because we're not doing that, but we're not doing the Qt basic. We're doing that. We're getting to the bytes free, so that's printing bytes free. So we're not really worried about that. We're not doing that. Okay, that's where we're running into the issue. Go restart 6C00100. That is the top of RAM. And it's plus 100, so that's 101. Why does that? Go restart location, that's 00. Okay, so go restart plus 1. Oh, okay. So cold start location, cold start location. That's oh no, wait. Are we actually doing that? Okay, let's see. We've got in our program. Now memory map, we've got these ones here. We're going to be overriding with the monitor. That one there, I don't even know what I'm using that one for. Delay, we're not going to be using. These three here, we're not going to be using. Okay. So, I don't think I'm even using the character store. We can look in our monitor that I've still got running. Hopefully it's still running. If we go 1234.100, that's the first page. Okay, so let's go back to here, because if you've seen that, that's what I've seen. But 4C, that's DD15, but we've got 4C15 there. And if it is calling 15 4C, that's where it will be falling over. But we see here 372B. That may not be the case though. That could be a issue with it calling an error. An area. No, it would still not work because we're 2 to 4. Got to remember backspace doesn't work on this. It's not the keyboard. The program doesn't like it. What do I do? What do I do? I go back here and we look at the OSI.list. So go restart 1, go restart plus 2. So go restart actually goes all the way back to restart. Where does it get out of restart? Which means that DD15 is the control F. Cold. Find. Okay, so that's back to there. It's a JSR, so we're going to be jumping to that. We've already done that, so this is not easy to follow. Especially if we go D15, so you can't find D15. You don't know that's DD15. And where's our basic? So DD11. What is DD11? What is DD11? It's 1D11, of course, which was what that other program told us it was. So let's look at 1D11. See, 1D11. No, that's D11. I want to do 1D11. 1D11. So we're looking at DE20. Okay. DE20. Because I've got DD10, which is A0DE20. And the one before that is A952. Which is up here. But then I've got DD15, there's 4 bytes extra. A2FF. I'm just having a look at the hexadecimal code. Then I've got A2FF 8688A, and that is 90. I'm well and truly stumped. That's all I can say. Well and truly stumped. Okay, so what we're going to do is just go through here. So QT memory size. Let's look for the no, let's not worry about it. Written by. Okay, where's memory size down through here? So, string out Qt memory size. Unless there's an issue with string out. It shouldn't be. Stringlet. Okay, so when this is done, it will fall through to that bit there. And then it goes through an RTS or JSR. There's an RTS there. Alright, so we know it's working. That's not what I wanted. We know it's working up to a certain point, and where was that certain point? After it does this print here. So where's our list? Qt memory size written by. Okay, so RAM start 2. Is at 300. Okay, so at 300, that's where we're starting to write data. Okay, that's at 11, which is in the 0 page. Which is that one there. And load Y. So it's getting terminal window width, and that's after a certain bit, and then we're doing the Qt bytes free. Ah, there we go. I missed the JSR. I got confused here. I missed that JSR. I saw the jump. Okay, so where is that jumping to? And that's control copy, and we will go into labels. Okay, C467. Okay, so that would be a good point to start to, let's see here. Let's get rid of this. Okay, let's get rid of putty for a moment. Okay, config scratch order and then JSR. Okay, let's compile basic. If I can find where I put my basic compilation and stuff. And basic's compiled, computer's off, take the basic ROM out. So the computer will run without it. Actually it won't, it just went to straight to E004. That's interesting because it should have just run the well, that's probably where it found a break. E004, but let's not worry about it. Let's program the chip. So at the moment we are looking to see where we are failing in basic, and from there trying to understand why it's failing. And we've been 2 hours. Okay, so what we'll do is I will okay. Okay, DD15 is where it loads again. Okay, C274. It's the warm start location. And the warm start location didn't work either. Maybe because it's sort of out of kilter with the extra 2 bytes. So C276R, and that still gives us nothing. And A0, and we do 50, just 0 at all. See how well that breaks it. And breaks it fine. And we just do a DD15R and 8192 50.60, and it is A0 that it is trying to run code from. A0.60 A0.AF. So 3C04. It doesn't make sense. It doesn't matter that the stack is shagged as well. Let's get rid of the break and the no op. Recompile it and see if we get the same result. Ooh, I didn't compile it. Did I? I don't remember. Yep, compiled it now. Okay, you can probably tell I'm tired. I forgot to bring up the putty screen. So we'll just quickly rehash what I've done. So at this point we have, where are we hiding here? Is that funny symbol? There we go. So at this point I have reloaded the ROM, started it up, and we've entered 8192, tried it again with a reset, 8192, checked where we're returning from, or the break is coming from, which is that address there, 00A0, then just confirmed it multiple times that it's that address, looked at the RAM where it's RAM start, and seeing what's happening here, and then it's C0 0 page, and you can see that it's the start address is DD15, and from there we are literally just going over and over what's going wrong, and at the stage I'm at a loss. I'm just redoing this to see if that break actually did its job where it's supposed to, or something else was going on for that break. Okay, so let's bring up the code so you guys can see, and then the terminal, switch on 8192. Okay, so syntax error, 8192. Interesting. Crashed it. So same place. DD15 has been stored twice. And that's the start of RAM, and you can see there's a lot of data being entered in there. And let's go to this one here. It's easier. No, we can't edit that one. Bloody hell. Let's remove that. That's really not working in our favor anyway. Okay, so what I just removed was, and I didn't realize you guys see it, I just removed the jump reset, jump to basic. We're going to just call it from the button again. What I was looking to do was go down and find the memcheck code and see if we have still got a decent amount of memory. And that is all the way down through here. Okay, so I just can't remember where it starts. 60. We start off at page. Well, what's the third page? The third page, and all 32. And then we do the mem test, which is it a JSA yet? It's not. Nice. Let's find the address of the mem test. That doesn't work. E4BE. Remember, this takes a while. That's 60. Oh, excuse me. Okay, 67 and 68. And so we do 67.68. And I don't know what's going on. Okay, so first things first is we shall put the ROM back into a known state. This is the boot ROM, and make sure it runs. From there, I shall leave you to it. And let's see. Oops. So reload that and bring up the putty, restart it. Starts at that address. And if we look at the 0 page, we can see that there has been nothing in there. And then we do the 300 to 3FF, and there's nothing in there yet. 50.5F, 50, we'll clear that. Okay, 50. Okay, so that's cleared. And we shall do a M, which is load basic, memory size 8192, terminal width 72. Now it works. I have a prompt and I don't know if this is actually working properly. I'm scared. Holy shit, it works. Huh. Oh, wow. Yeah, cool. Control C. Control C doesn't work, but, wow. Huh. Let me blow my nose. I'm going to be back with you. Okay, so I'm just going to reset it. I don't want to do this because it works. And let's figure out where I have not got my Control C working. Now, Control C is... excuse me. Control C. That's our check memory. So I don't know if it's coming back from here. Okay, I don't know if it's doing that. We don't need any of that anymore. We just need to run basic. Goodbye to that stuff. Report memory. We're going to have to work on that one. check memory. I've already got that down there, but I need to do it for loading some addresses. Okay, so this is LDA 0 string. Immediately load the value 03, so sta into location called memtest start, into the location called memtest start, LDA hash 32 is a one of those numbers, sta and mem test end, and then we JSR to memtest, and that will do that. Control C is probably not working. JSR get character. And 3. Control C. Okay, I want to check to see if this is a fluke. Yep. Error in 20. Oh.